This is problem 5-73. Avery and Colin were trying to challenge each other with equations for sequences. Avery wrote t of n plus 1 equals t of n squared minus 1, and t of 1 equals 3. Help Colin write the first four terms of this sequence. Alright, so I know we need four terms, so I'm going to put four blanks. So our first term, second term, third term, fourth term. So let's look at this first part, t of n plus 1. So on the last page we talked about t of n plus 1 is the next term. So next equals t of n is current, but there's a squared on it. That's the only thing that's different. So that means we're going to take the current term and square it. So current, and I'll put a little squared up there. And then we have our common difference, which is minus 1. The next line, that t of 1, that means the first term is 1. So they told us where to start. We know the first term is 3, not 1. The first term we know is 3, so we can fill in that blank with a 3. How are we going to get the second term? So we're looking for our next term. So let's go up here. Next equals current. So we're thinking, what's our current term right now? Well, our current term is 3. So we're going to do 3 squared and then minus 1. I'll do it up here. So 3 squared minus 1. So we have 3 squared is 9, minus 1 is 8. So that means our second term is 8. Alright, now we're done with 3. We're moving on to our current term, which is 8 now. So if we're looking for our next term, we're going to do next equals our current term squared. So now we're doing 8 squared minus 1. 8 squared is 64. Minus 1 is 63. So our next term is 63. Finally, this is where our numbers get kind of big. We have to use 63 as our current term. So now we're going to do 63 squared minus 1. 63 squared is 3,969. Now we're going to do minus 1, so we get 3,968. So again, our fourth term is 3,968. B. Is Avery's sequence arithmetic, geometric, or some other kind of sequence? How do you know? Okay, remember when we talked about types of sequences, arithmetic is adding or subtracting, geometric is multiplying or dividing, some other kind of sequence means it doesn't fit any of those. So if we're looking for a pattern in these, well, that's adding 5. These are clearly not adding 5 every time. And then if we multiply, I don't think these are multiplying by the same number every time either, so it's not staying consistent. So this is going to be another kind of sequence that we don't know what it is, so we're going to say other. And how do you know? We can say there's no consistent pattern. Alright, let's go on to C. Describe to Colin how he could find the 10th term of this sequence. You do not need to actually find the 10th term. So we just have to describe how to do it. We're not going to extend our sequence clear out there. So if we're looking at this up here, next, our next term we're looking for is the 10th term. So if we're looking for t of 10, we're going to assume that we know the 9th term, since the 9th term comes before the 10th. And that's the only way in a recursive sequence we could find the 10th term. So we want the 9th term. So if we're looking at that t of n squared, or our current term squared, our current term is going to be the 9th term. So t of 9, we're going to square it, and then subtract 1, just like we did first. So in other words, what this relates to is, or I guess in real words, 10th term equals 9th term squared. And then our last part, minus 1. So 10th term, we would take the 9th term, square it, and then subtract 1.